conventional. So this is what I decide, that this direction will be positive because this is direction of my movement. That's the clever things to do, make the life easier. Force of friction, which is the kinetic friction, of course. There is make it bigger. There is a tension out of the object toward the road. I call it force of tension. And here is going to be force of tension out of the object toward the rope, force of tension. These two force of tension will be the same because this is just one rope connected without any disruption. I have here the gravitational force downward. I call it FG2 because now I have FG2, I know FG1 here, and I have a normal force. So these two forces are kind of internal force canceling each other, right? If I want to consider the whole system, which for finding acceleration, first things you do, you look at the whole system, right? This is what we do. To find the acceleration, this is the whole system. To find acceleration, look at whole system. Internal force cancel. It's good because I don't know some of those internal forces, right? And make looking at the whole system make my life easier to find acceleration. Okay, now means total force of the system is equal to total mass, which is m1, try my best, right? Plus m2 multiplied by acceleration. Now, what is this total force of the system? See, internal force, which is the f of t and f of t cancel because they are in opposite direction. If you open it up, this is going to be in opposite direction. The only force acting, and of course, f of n and f of g cancel. The only force matter is f of k here, and this is f of g. Since f of k is opposite to the direction I considered, that would be negative and that would be positive. It's going to be f of g2 minus f of friction, kinetic friction, equal to m1 plus m2a. And everyone know that fg2 is equal to what? m2g. This is m2g. And remember the force of friction is going to be mu k, multiplied by force of normal. This force of normal, it is equivalent to f of g, right? The magnitude, they are equal because they cancel, is equal to m1g, right? So instead of the f of n, we will just write down that here. Force of f of k is equal to mu k f of n, and this f of n is equivalent to m1g. So it's going to be m1g. m1 plus m2a. I'm going to rearrange for a. So it's going to be m2g minus mu k m1g divided by m1 plus m2. Now I can plug the numbers. m2 is 14, g is 9.8, mu k is 0.21, m1 is 8, and g again is 9.8 divided by 14 plus 8. I'm gonna quickly put that in a calculator. Okay, I'm gonna just explain it again because I didn't record it. So I'm choosing this object to be to calculate tension force. I'm choosing the second object. You could choose the first one. So total force on that is equal to mass multiplied by acceleration. The mass of this object, of course, is m2. I put this direction to be positive. So f of g2 would be positive, f of t negative, equal to m2 multiplied by a. So just nest the total first, f g2, because two force acting on this object. F g2, which is positive, because I take this direction to be positive, and f of t negative. I take that and bring, and instead of fg2, I put m2g, bring ft to one side and m2g and m2a to one side. We put factor m2 and plug the numbers, put that in a calculator. Minus 5.488 is 60.36. Okay, so 60, don't have a space, 37 Newton. Don't forget the unit. That would be your force of tension, right? Is that? Okay, great. So let's move on to the second one. I want everyone to take, okay, example 2. Two sleds are tied together with a rope. Coefficient of static friction between each sled and the snow is 0.22. Small child is sitting on a sled 1, total mass 27 kilogram, and a larger child sitting on sled 2, total mass 38 kilogram. And then I'll pull on his sleds. Determine the force of the adult can pull with before the sled moves. Okay, this is a good question. This is a picture that I can help you with. We have two sleds. There is connected with the ropes. Actually, there is force of apply here because an adult pulling that. Sled 1, you just let an snow is okay. Mu k is given to you, or actually the static friction. Mu is given here. We call it a sled 1, and here is sled 2. So this mass gonna be 27. A sled 2 is gonna be mass 2, will be 38 kilogram. The amount of force of can pull before the sled moves. So before the sled move, it means just is began to move, right? It means you have to consider the maximum friction, you overcoming that maximum friction. Okay, I'm just explaining until here. So you need to do FBD diagrams and try to figure it out. Give you some time to do it. Okay, so first thing we do is a FBD diagram for each object. So for this one, for sure, we have force of gravity. I call it FG1. And force of normal, Fn1. They cancel because your object is not moving up and down. Same thing here, Fg2. Gravity and Fn2. Since this object is moving in this direction, I call this one to be a positive direction to the right. So the friction gonna oppose this the movement, right? I know it's not gonna accelerate. Maybe this is a bad decision, but it's kind of trying to move in this direction. And this direction gonna be more positive. And a friction opposing that attempt, right? So it's force of friction, and it's gonna be static because it's just when it start to move, right? It's a maximum. F S force of friction S2. And again, this is what we want to do. We want to just overcome the maximum static friction, right? To do that, I need to apply a very high force After I just get this one to started, of course, I need to apply less force to keep it moving. Okay, that's the idea. Now we're doing it, okay? What was it? And of course, we have a tension force. We don't need it because I'm gonna um, look at the whole system, right? But I'm gonna put those tensions, F of t, and this F of t is gonna be the same because this is just by one rope and they connected with this rope is not disturbed at any of those, is not disrupted, right? Okay, determine the force arrow can pull weight before the sled move. Means I need to find this force of apply. Okay, before it start to move, it means the total force, the system force, I know is equal to ma. When is just a start to move? Before. When the force before the sled move means it's not moving, right? Before it move means not moving, or there's gonna be zero, right? So what are the forces? It's gonna be F of A, gonna be positive. I have a force of friction, which is negative on a sled 1. And I have a force of friction on a sled 2. Do I include the tension? No, because this tension is positive, this tension is negative, they are equal, so they cancel each other, right? Do I include F of N and F of G? No, they are in Y direction. Also, they cancel each other. So just be aware of what we do. Now let's just talk about FS1 and F of friction for static friction for the first sled and force of friction for static friction for the object 2. That would be mu s f of n on object 1, mu s f of n on object 2. I know that's gonna be mu s. Force of n on object 2, of course, gonna be m1g, and here is gonna be mu s m2g. I can put the numbers, or I can just plug that in here, and after all I do this. So f of a minus mu s m1g minus mu s m2g is equal to 0. Just add them up. So mu s m1g minus, oh, actually this one to the other side, become positive, this become positive, yeah. Mu s m2g. Make it nicer, you can factor out mu s, you can factor out g. It's gonna be just m1 plus m2, but you could do it without that. Mu is given, it is 0.22, the g is 9.8, m1 is 27, m2 is 38. I need my calculator. This is the force that you need to apply to make it move, right? To just make it and start it to move. Any question? Example 3, a ball with an unknown mass is rolling on the ground at an initial velocity of 15 meters per second east. The ball comes to rest in 5 seconds. Determine the coefficient of friction between the ball and the surface of its traveling. I'm going to make some picture for you. So this is the object is rolling. We have initial velocity 15 meter per second east. The ball come to rest because there is a kinetic friction. That's why the final velocity would be 0. And this is happening for the 5 seconds. I want to find the coefficient, determine the coefficient of friction between the ball and its surface. I need to find mu of K, right? So that's the total picture of this question. I'm going to give you some time. Write your answer in a chat. Okay, a ball with unknown mass. Okay, I just put the information here. Okay, great. Now the first things I need to know, let's just put a video diagram. I know there is a gravitational force always, right? And there is a normal force that cancel because my ball is moving up and down, right? There is a frictional force. Is there any other forces? And this is kinetic. I wanted to make it better. It's look like it's look good, right? So this is the force of friction. This is kinetic. I know total force on an object is equal to ma, and the only force acting on object is going to be frictional force, right? Also, I know frictional force is mu of k multiplied by force of normal, and force of normal is the same as mg, true? Because f of g is mg. So that would be a good question for a test because sometimes, let's say I'm not gonna give you the mass of the object, right? You don't need it. Since the mass and mass will be canceled and the mu of k here is just its acceleration over the gravity. But since we do not have acceleration, I need to get it somewhere. So I have these three information, so it's good. So I can find acceleration from here, right? Kinematic. So V initial power, which one do I use? Okay. V final is equal to V initial plus AT. Or acceleration is velocity final minus velocity initial. That's the same thing, right? That would be better. So V final is 15. V final is 0. V initial is 15. Time is 5, so it's going to be negative 3. So this makes sense. It's going to be negative 3 because it's stopping, right? So, um, since I could put negative here, kind of, that I forgot, see? I have to make it negative, true? Because if this is my positive direction, that would be a negative. So I forgot to do it. So that's why you'll get a negative somewhere. And your acceleration here is negative 3. Your g is negative 9.8. Now it's good because the mu doesn't have any sign, right? I need my calculator.